Recording has started, and this is the June 25th, 2026 Crossplane community meeting. Let me take grab the URL and drop into the Zoom chat here the link to the agenda document if folks don't already have it. And you can pop into the agenda document and add any suggestions or comments that you want to. Feel free to do so. And let's start with update on latest releases. So I think we did 2 rounds of patch releases for upstream Crossplane since the last community meeting that we met. Let's talk about a couple of these real quick. So 2.3.3 was released earlier this week. And then the thing to note in this one, so both 2.3 and 2.2, I think they were both .3 patch releases. We had a security advisory. We always have security updates, etc., for our dependencies. There are many of those these days, but we had a security advisory from a community member that they submitted through our security disclosure process in Crossplane's package manager. So for this one, and we'll bring up the advisory so folks can see it. If you had signature verification turned on for your packages, Adam, is that still an alpha feature? I can't remember.
Yeah, I forget whether it's an alpha feature or not, but in addition to turning on the feature flag, you have to explicitly configure it with an image config.
Got it. All right. Yeah, so if you're using that functionality, and then you're using tag references, if you were installing packages from a malicious registry that you do not control, there was a time of check, time of use issue in the package manager where we would, verify the signature of the package up front. And then when we go to actually fetch it later on, we do not verify it a second time. And so if a malicious registry had wanted to exploit that and serve you a different image, then we would not verify it and we would run the malicious image. So that issue has been fixed, patched, and released in the 2.3 and 2.2 branches. So that's available for you. So thanks a couple of different community folks, both independently submitted this issue here. So we really appreciate getting that. And we also are glad that the fix is out there into the patch releases as well. Couple of other updates. There's a continuing theme for the high fidelity render command that we released in 2.3.0, I think. I've done a couple patch releases to continue improving that and making that meet the expectations of its downstream consumers, like the Crossplane CLI. So a couple fixes there as well. The other patch release to note, I think is this one, 120.9. I was going to talk about this a little bit later, but we're talking about releases now, so let's do it now. We did a 1.20.9 release a couple weeks ago, or 3 according to this. And the big thing there was that we actually shipped a new Crossplane CLI feature in that patch release. The entire intent of that feature there is a Crossplane beta upgrade check command. And what that does is it runs and executes against the control plane that you pointed at, the V1 control plane, and it looks for any of the features that were removed or altered in Crossplane V2 that would essentially inhibit you from being able to smoothly upgrade to Crossplane V2. So it's kind of a tool for you to check your control planes, make sure that they're ready to upgrade to V2. And it's available in the 1.20 branch only, since if you're already on V2, it doesn't you don't need to check anything. So we shipped it only in 1.20 in the .9 patch. So the latest 1.20 version there has that. And definitely happy to hear any feedback from folks that take it for test spin, use it on their control planes. If you've run into any issues, please file issues for us. Let us know so we can make sure that we continue to improve that experience there to help people understand when they're ready to upgrade to V2. So I think those are the highlights from the recent set of releases that we've done. The current milestone we're on right now is 2.4, and we are looking, in the August timeframe for doing the 2.4 release. So still a couple months out, I guess. We shipped this one already, the V2 upgrade check tool, so that's done. Christopher Har, I know that you are owed a review still, and sorry for not doing that, on taking the deletion protection work that you had done in the last release for providers and extending that to XRs and configurations, etc. So we definitely want to ship that and include that.
And there's a couple of questions open for the other maintainers in this PR.
Like design decisions type of stuff.
Yes,
Okay.
if we want to unify the arguments and so on. So it would be cool if some guys can have a look at it.
Yeah, for sure. Yep, we owe you a review, my friend. All right, and then is Bob on the line today? Normally, but not today, I guess. So I know we want to make some progress on some of those management policy extensions for like core reliability stuff, and I know there's lots of awesome PRs for the community as well, as always. And thank you all for those. So we want to keep making progress on those as well. Let me just bring up the release board real quick. One that is definitely worth noting is this one right here. So in the Crossplane tools, people forget about the Crossplane tools project sometimes until it's needed to be updated. It does a lot of work in the background for automatically generating method sets for providers so they conform to the managed reconcilers expectations, et cetera. In 2.3, we did some refactoring to move the Crossplane APIs into their own Go module so that we could also break the Crossplane CLI out into its own repo, et cetera. One of the impacts there is that the Crossplane tool set here is needs to be updated to support that move of the modules. So there's community PR open here. It's been open for a little bit. And there's been a little bit, we've got some reminders on it there. So I think this is important. It's blocking people from being able to upgrade their providers to 2.3, basically provider authors, that is. So we've asked Adam to take a look at it. So Adam will be following up on that. And thank you for doing that. So yeah, I think that's I put that at the top of the review column right now for the work in 2.4. So we can get that out as soon as possible. Yeah. Okay. So lots of stuff to do, lots of stuff in progress, lots of stuff done. A couple months, month and a half or so left on 2.4. So happy to see that progress there. And thanks everybody for working on that so far. Let's keep on moving to the ecosystem updates. Jonas, you're here to give us a little summary of some of these updates, my friend.
Of course. So the last month was busy, as you can see. We did few releases. We've released Abject 2.3, and that completed rollout of the API versioning policy. It's linked here, and that allows you to roll out API versioning in cloud providers. We've rolled out it in major cloud providers like Azure, AWS, and GCP. And that allows you to start the deprecation process of old MR API versions. On Abject topic, we've also released reconciliation API for provider configs. That means that you can now set reconciliation policies via provider config, for example, base and max delay of the reconcilers. That was merged in Abject, so you can use that in any Abject-based provider if you would like. And Abject, yeah, exactly like this. It is already rolled out in AWS, Azure, and GCP providers. So you can use that as a reference point for your own provider implementation. We've also added API round-trip testing library in Abject. That allows you to ensure round-trip correctness between your generated API types. If you are using, for example, singleton list to embedded object conversion, now you can check that all your types are round-trip correct. And we've also integrated that API conversion library in multiple providers, mostly major cloud providers like AWS, Azure, and GCP. On that topic, we've also had multiple minor releases of providers, mostly the major cloud providers. You can read the release notes. We've added multiple new resources in those minor versions. We've also released few patch versions of the official providers with bug fixes and CVE remediations. And multiple major cloud providers received new resources. Here you can see the list. It's also added in the release notes. The rest of the ecosystem also got a few updates, especially in the function ecosystem. Notable release was function auto ready v07. Major highlights are that you can now configure response cache duration, and there's also an alpha feature that allows you to configure a custom health check using cell expressions for resources that, for example, do not expose conditions of type ready that are used by default by function authority. So you can either pass it via environment config or inline in the composition if you would like to. And I think that's everything from the ecosystem updates for this month.
Awesome. Yeah, a ton of work there that's being done to especially around all the API versioning and like that's what I found over a couple of years is that versioning CRDs and the storage version and like changing the like conversion webhooks and all this jazz is very complicated. And so the investment being made here to give us more flexibility and reliability as well for the major providers that do go through changes over time is very, very impactful, I think.
I agree. And from the major investments into ecosystem, I would say that the releases we've released Abjet with all the new things that I've already mentioned. And we are also having a look into new major version release of provider Abjet GCP, which bumps Terraform version. Plus, we are doing multiple investments into capabilities of provider Helm and working on agentic skills for Abjet provider review and development, so that you can offload some of your efforts in those providers to agents.
Oh, interesting. That's interesting as well. Okay, cool. Anything else to add for folks from the ecosystem about any functions, providers, etc., that folks maintain?
Nothing from my side.
All righty. Well, thank you, Jonas, for that update. That's definitely better than if I would have tried to talk through those notes there. So your expertise is appreciated. All right, let's keep on moving since we do have two speakers today. So yeah, a couple quick notes. There's a couple of recent blog posts on the Crossplane blog. This one is basically a blog post about the beta upgrade, so the upgrade check command that we were talking about to make sure that your control plane is ready for V2. So if you want to dive into that, some of the details about how it works and what it does are in this blog post. And Nick wrote an awesome blog post about how and you will see more details about this later on. Nick is one of the speakers today, but dives into a lot of the details about how we built the model plane project, which is essentially one of the most complicated implementations built on Crossplane yet. So there's a lot of good tidbits in there if you're building real platforms with Crossplane. So worth a read there. Nick will go into some of the details pretty soon here, though. So I wanted to do a little call out here to KubeCon North America in 2026 in Salt Lake City again. That's in November, and there's always opportunities for folks to get more involved. If you want to take a shift at the Crossplane booth and hang out there and talk to people about your Crossplane experience and share your expertise with folks that stop by the booth. Lightning Talk is an interesting opportunity to kind of share a 5-minute presentation to a fairly large audience there at the CNCF Lightning Talk section. We have the maintainer track talk as well. So if folks want to get involved with that, just reach out to me directly. And I'm kind of compiling a list of all the folks that are interested so we can kind of organize our efforts together. And it is months away, yes, but we have the deadline to submit our proposals for Lightning Talks and Maintainer Talks and all that jazz is like 2 weeks away or so. So that's why I'm bringing it up now. So don't sit on it. If folks are interested, do let me know ASAP. All right, Adam, you want to hit us with some CLI updates?
Sure. So yesterday we released version 2.4.0 of the CLI. This is the first release where the version of the CLI diverges from, I should say, core Crossplane, not upstream there, but diverges from core Crossplane. So the CLI is now at 2.4, whereas core Crossplane is still at 2.3. And this was one of the reasons that we moved the CLI out of the core Crossplane repo so that we can add features more quickly in the CLI, with the CLI being, I think, a little easier and less risky to upgrade for folks than upgrading things in your clusters. So there's no huge new features in 2.4, but there's lots of incremental improvements, a few new utility commands, new flags for some existing commands, and a couple of developer experience updates that came from Nick and kind of fell out of building the model plane stuff. So some nice things for people with more complex platforms that they're building with the CLI. So yeah, I think that's all on the 2.4. Next things up in our queue are adding tests to projects, so you can easily test your compositions, both at the like kind of render level and then also end to end. Theo is leading the work on that. The other thing that we've talked about in our SIG CLI meetings is the need for some end-to-end tests for the CLI itself, because it takes a lot of manual testing to be confident in changes right now. So we'd like to have some tests there. I don't think anyone has picked that up yet. So if anyone's interested in building an end-to-end test framework for the CLI, I would love to have that as a contribution. But if not, I'm sure somebody will get to it eventually. And the other thing is we should start talking about promoting some of the alpha and beta commands through their life cycle. We've got commands like top and trace that have been around for a long time and are still marked as alpha or beta. So we should figure out, like, is there anything we need to do there to call them more mature? And if not, then we should just do it. And if there are things we need to do, we should do them and get those things into beta or into GA.
Nice.
I think that's it on the CLI side.
Great, Adam. Thank you for the update there. And yeah, it's awesome to see the increased velocity that we get across Crossplane CLI now that we have, lives independently and versioned independently. So I expect this number to continue increasing.
The other thing I would just call it is we've had tons of contributions from lots of people in the community. I think lots of first-time contributors. So really happy to see that on the CLI, and I think it's a great place for people to contribute, even if they don't want to dig into like the guts of Crossplane reconcilers and all that stuff.
Yeah, good point. Lots of opportunities. Okay, cool. So next one, I just wanted to mention that so the SIG, the special interest group for V2 migration stuff, has we've officially kicked that off here. So a couple things to note. I've opened a discussion issue to kind of get us organized in a single place here, with all like the current notes and resources, et cetera, around migrating to V2, and a couple of call to actions here to how to get involved. So we'll have, in the SIG group, we've got our first kickoff meeting for next week in the exact same time slot, 1 week from today. So feel free to join there. The calendar link here will get you there. And then there's a survey as well too. Like, we got to get some data here around, how folks are how are approaching migrating to V2 right now, any sort of hesitations they have here, what they'd like to see in the Crossplane project support for you. So lots of ways to get involved here. Probably the most pressing one here to immediately participate in is the survey. So do take a minute to fill that out here, so we can get some more data around and inform us on how to best approach migration to V2. And then, of course, we already checked about the upgrade check tool that shipped in 1.20.9. Okay, sweet. So we've got like almost 40 minutes left, two demos, presentations to give here. So let's give the rest of the time here, and we'll want to talk to this PR too. But yeah, almost the rest of the time here to Chris and Nick, about 20 minutes each or so. I don't know how much time you guys need, but that's a good chunk of time for the both of you. So take it away, Chris.
Yeah. Hey guys. Yeah, thanks, Jared, for inviting me, and I will show a bit what I was working the last weeks or months on something like a Terraform plan equivalent for Crossplane. So if I remember, like the last 4 or 5 years, that's like the most requested things I hear from folks outside in the community across issues, and also from customers from Upbound, right? So people want to see at the end of the day what changes does before they're applying it to real control planes or to real clusters enabled with Crossplane. They want to see a diff. They want to have confidence before they're hitting the go at the end of the day, right? And I was thinking about how we can stop this long-standing gap here. The cool part here is that the community in the past taken the real swings here. So when we released the Crossplane render CLI first, there popped up a bunch of community-driven projects to get a first idea of diffing something, right? So you were technically running something like a crossplane render on your PR branch, then you're running crossplane render on your main branch, then you're diffing both, you get an output, and you have some toolings around that you get some confidence if changes in your composition engine can break something in your control plane, right? And then there is there's one thing from John, thanks for this, crossplane diff, which takes a little bit closer to the control plane, right? So technically it is rendering your XRs against like live cluster states. So it getting like the resource refs from your XRs. So it renders as long as all the required resources are fulfilled, and it also taking care of nested XRs that you have a good overview what can happen if you're applying your change to your control plane. And then there's also some things we doing in Upbound, right? So some guys from our engineering teams, they implemented something called simulations. So technically it's cloning a full control plane, it's applying a change, it's shutting down providers, and then you get a full diff what will happen in your control plane that you have an idea of what's going on, right? And all of the solutions at the point are good, right? They are useful and many people using them, right? But they have all the same boundary they sharing, right? All stops at the render command at the end of the day, right? So at the end of the day, what you're getting out of all the tools is the YAML out of your composition rendering, right? And it shows you at the end of the day the managed resources, and you have an idea what would be created or changed, right? But there's one part missing here. You don't know what the provider will do with the resource at the end of the day, right? You see a change, for example, on a, let's say, RDS instance, and does bumping an engine version will do something with your RDS instance? Is it like an update in place and AWS will tell you, cool, I updated your RDS instance? Or is it something like you need to force destroy your RDS instance, you need to recreate it, you need to spin it up again from your backups, from your snapshots, right? You don't know it today. You need to, at the end of the day, you have the knowledge, or you need to figure it out in your dev control planes and then staging it to production, but you don't know what's going on, right? And there are other things. If you're not confident enough at the beginning in developing all your compositions, so what kind of fields will be available after you apply the resource? How the output of specific field looks like, right? Do I know only like a few fields after I apply something, right? Does providers from Crossplane ecosystem injecting tags? You don't know this upfront, right? You need to apply it and then you will see it perhaps, right? The next thing is what the provider upgrade will do. Does, for example, a provider implements a new field which requires in replace of your full resource, which happens from time to time, right? And all of this, we have no answer today from render. The hard part here is the render don't know about the cloud. Only the providers know what or how the providers can talk with the cloud, right? And that's it. The hard part here in our community is we have three kind of providers at the moment outside, right? So the native implemented providers, and then we have object-based providers like, and technically we have fork and no fork object providers, right? So the bigger community providers running on no fork and the other ones on fork, which is running like some Terraform CLIs under the hood. But the cool part is for the object-based, and it doesn't matter for fork or no fork, we can make it possible that we can run the Terraform diff machinery under the hood, right? Relatively easy. For the native providers, it's a little bit harder because you need to figure out, like, if you're doing something like this diff machinery from Terraform, what does it mean for specific fields? Because we have the native providers no markers. Does this means enforce replace often resources needed if you're updating a field, for example, right? And to show you what I did is perhaps the easiest thing here. And then we can talk about this a little bit. And I will share my screen. So can everybody see my screen? So there's some false code. Docker
Yep,
desktop.
see the entire desktop, Chris.
Yeah, that's cool. That's cool. So first of all, I implemented this in UpCLI, right? Because this work started when Adam started to upstream the project functionality, right? But it is technically the same thing than in the Crossplane CLI if we as a community decide to implement this feature what I'm showing you upstream. So I have here in control plane available. So let's have a short look. Let's make a trace here. It's platform ref AWS deployed. So you will see it has one XR and it has a bunch of nested XRs under the hood, right? So you see local answer controller, EKS, network, whatever. I have here only the network project checked out, and I will update here something in my composition, and then I would guess what will happen in my live control plane if I would release this and roll it out, right? So the first thing what I can do is then something like a project simulate, and thanks to John, this is very similar what you're doing, but as I said earlier, it goes beyond this because I have providers equipped with some gRPC server, and this gRPC server accepts some state from a resource out of a cluster, and some intended change I will render out of my change here. So if I running this now, then it will connect first to a cluster. You see one composition in the project found, one XR to simulate, and then it's preparing dependencies. And you will see now here, I'm starting all the dependencies which have a gRPC server available. So there's provider AWS S3 and then provider AWS EC2. Then I'm rendering the full project locally. And now I'm simulating what's happening, right? So it started a few functions. It's setting the observed and required resources, and then you get an output, right? And you see there's no changes at all at the moment, right? So cool, it's the same like the old render machinery. But let's say, for example, I'm setting here a completely different IP address in the CIDR block, and some guys are familiar with AWS. This forces a recreate of the security group rule from the provider. So technically, this resource after apply to a live control plane gets stuck because we're not recreating resources with the providers, right? So you will see only an error message that this is not possible to update, and then you can figure it out yourself what you need to do. If you are running the simulate now here again, and in a few seconds, we will get an idea that this field forces in replacement of this resource, right? And because of we not forcing replacement, you get a warning here. So that a specific field here required the cloud resource to be destroyed and recreated, and Crossplane will not auto recreate, so a manual intervention will be required. So if you know a little bit familiar with the how the Crossplane thing here works with metadata name, right? So let's say, sorry, this was too fast. Let's say the cool part is I can also say, okay, let me rename this here for a second and see what happens then, because I cannot fix without a manual intervention on the cluster this change of the CIDR block here on the security group rule, right? Then I running this again, and then we will see in a bit that we will get a new resource created, and the old resource gets destroyed automatically from Crossplane because we changed the composite resource name here. So wait a second. So and then you see, cool, there will be one new resource created because I updated the composition resource name, right? And then you also get an idea like what kind of fields gets filled from the provider after an apply, right? So you get a security group rule ID, for example, or the source security group ID, perhaps filled from the provider after it's really created against the cloud, right? And you see that the other resource gets deleted. So, and you can play around this now with every resource. Technically, let's copy pasting for a second one of the resource. Let's giving it a new name, Jared. And if you're running it again, then we'll see also for the security group rule what will happen on the provider side. The cool part is technically I can also send all of my resources from a control plane to this gRPC servers. And if there's a newer version of the provider available, I can see what's happening, right? If the provider, for example, is not accepting any more specific fields because there's a breaking change, then I get an error, right? So that this or that field is not allowed anymore to set on a resource, and then it's breaking, and then I have an idea to do something. And I see, I guess also Alper is here from one of the Upchat maintainers. In detail, there's a bit things of work to do with my solution when it comes to multiple versions, right? We have conversion webhooks, so technically I'm only like getting the latest version, right? It's not the version which is stored in the etcd. It's the latest version what I get here. So the internal machinery, like using this, right? But perhaps there's something we need to discuss if this is enough to get a good overview of what the provider is doing here. So I think that's technically it. Because John is doing something similar in the Crossplane diff command, you can also say in up project simulate -- full tree. So it is searching now if the XR which finds belongs to a parent, right? And then it's rendering the parent completely a few times until everything is successfully done. Bad that I decided yesterday evening to updating the Crossplane CLI and internal render machinery because observed resources are not working at the moment somehow. So you will see now a bit diffs because of an issue. I already reached out to the Slack channels, but you will see now that it's simulating the composition tree, and then I get a full overview from all the resources. And then you will see also something interesting here, because if there's no gRPC server available for getting the diffs from the provider machinery, right? Then we're falling back to a simple diff between spec for provider and status at provider. This takes now a bit, and you see the machinery here is doing the things. So it's starting with a bunch of functions and putting observed resource and so on and so forth. The gRPC servers from the providers are still there during the full run. And then you get here for every you're getting then for every XR which is found in plan what will happen. And you see technically the CLI thinks at the moment it gets deleted because the observed resources are not passed away. So this was working a few days ago, but not with the newer versions. Because we have some Upchat maintainers here, let's have a short look how this is implemented in the providers. So technically, it's relatively straightforward. In my working branch here, I replaced the Upchat version to my local one, right? And then I simply updated the main Go template for all of the scope providers. The implementation here looks very similar to what we're doing with the internal render and Crossplane. So I implemented like an internal plan server command that you can start the providers with this plan server, right? And then at the end, I have a function to run the plan server. The one thing you need to take care on is specific providers are only responsible for specific groups, right? So the monolith is for everything in the AWS group, and in scope providers only for EC2, for example, responsible, right? And that's what I'm setting here, that you have an inform endpoint in gRPC that you can see this. And then if you're running like a make generate, then you will see that all the generated main goals gets automatically injected this plan server command, and that's technically it. On the provider side, on the Upchat side and TLDR, I will open some some ARC documents, one-pagers across Upjet and the CLI, and then the community can decide how this gets implemented. But technically, I have like the proto implementation for this endpoint. I have a server which has a get info endpoint for which groups it is responsible. And I have like this plan endpoint available that you can set like resources and get a plan back. And that's technically it for the full render machinery. I relying most or less on this what John already did in Crossplane diff CLI. And I guess that's technically what I wanted to demo today if we're looking at the time. Yeah, I think that's a good opportunity to bring back the Crossplane diff CLI to the main CLI and making also the machinery from the diffs from the providers available for folks that they have an idea what's going on. I also want to mention Jonas at the end. Jonas, because in the Azure provider, it's a bit harder to make the diff from the providers because you need to hit the Azure's endpoints to figure out if some fields are deprecated or not available anymore. For that reason, I also implemented an option that you can technically set for the gRPC servers like credentials. So you could inject technically in your CLI runs credentials, right? OIDC, whatever, that you can really like make an observe call against the API endpoints and then get like in real describe and you see if some fields are working different than before. Yeah. Thanks of all. I will share in the channels in the evening the document, the PRs, Upjet, CLI, and then folks can discuss if this is cool to have or not. Thanks.
Awesome, Chris. I think this is something that's quite exciting that can really kind of get through like address some of the challenges with getting confidence of rolling things out in a control plane that have been present for quite a while. So there's a couple questions in the chat. I wanted to also check in with Nick to make sure that Nick has enough time for his part as well. Nick, did you say how much time you needed? I didn't ask you beforehand.
My part's going to be very casual. I haven't got like a concrete demo or I haven't practiced or anything, so it can take as little or as much time as you like.
All right. Let's see that real quick. Is there kind of answering most of the questions in the Slack? Oh, I think one of the questions then about like V1, V2 support. I think that's maybe the only one that wasn't addressed in the chat. Like, will this Chris? Will this be a V2 only feature, or would it be possible to run it with V1?
It is possible with V1. It depends more or less on the providers to an updated Upjet version at the end of the day, right? For the providers which are natively implemented, I have one version for provider Helm technically available to do something like this, right? Because this is a special one. I don't know what folks using as native providers, which helps to show them how to implement something like this. So.
I assume it also will require functions, right, Chris? It's if you're on V1 with like native patch and transform, I'm guessing that the render thing's not going to help you.
Yeah, it's functions at the end of the day.
Yeah, good point.
Actually, did we backport the native render subcommand to V1.2? I don't think so, right?
No, it's the new render stuff is only in 2.3 and newer.
Yeah, I was working since I was updated yesterday my branches. So yesterday I was working on 2.1 implementation. Everything was working. Now I have the observed issue with like the 2.3 and 2.4 implementation. So something to sort out, but technically it's working as long as I have the render machinery available, right? So.
Cool. All right, awesome. Thank you very much for showing that off, Chris. And so there will be more coming here in terms of like proposals, architecture designs, discussions, etc. So this is kind of like the first, hey, this is what Chris has been working on. It's definitely interesting. And then, collaborating with the community about what's the best way to integrate this into the Crossplane ecosystem, if the Crossplane ecosystem even wants it, etc. So lots of work to do here, but this is a fantastic start. And with that, let's go over to Nick now to talk about model plane and building model plane on Crossplane.
Hello. this is going to be super casual. I haven't got anything planned out. I'm going to talk more about how we built model plane than what model plane is, but I will start a little bit with model plane. If you see me looking over here, that's because where all your faces are for me, and my desktop is here. Um, and if you have any questions or anything, just speak up. I won't be able to like watch chat, and I don't mind. I would prefer to be interrupted, so just speak up and ask questions. All right, let me share a desktop. This one. Actually, as I started going into this, God, I hate Slack. I just years and years of terrible software.
Slack or
Sorry,
Zoom?
sorry, not Slack. Yeah, Zoom. I don't know. Slack's
Okay, I
fine.
was like, I like Slack. Zoom, I'll agree with you.
Some tangent. Let me tell you about this software I'm not using right now that I dislike. All right, so I realized while getting started with this that we don't actually have a great diagram for model plane at the moment that isn't kind of architecture. So I'm going to show you this architecture diagram that gives you an idea of what model plane is. So something myself and a few other people at Upbound have been working on for a couple of months. We have been seeing people using Crossplane to think about setting up inference stacks, AI inference stacks. A pattern we've noticed in sort of some of Upbound's biggest customers are that the people who are being tasked with running inference for their companies are the same people who use Crossplane already to manage platforms, and they've been doing it with Crossplane. So we thought, why don't we see if we can help with this and see if we can come up with something that could be a bit of an open standard for running inference fleets. And fleets is the key word there. There's a bunch of projects out there that do inference on Kubernetes. As far as I can tell, Kubernetes is kind of mostly what the bigger players are using to run their inference stacks. Got projects like Dynamo, Kserve that are running a Kubernetes cluster layer. And then you've got containerizable engines like VLM, SGLang, all that kind of thing. Model plane is designed to sit kind of a layer above and manage a fleet of inference for you. So the general idea, if you can see on this architecture diagram down the bottom, you have a couple of inference clusters, one on GCP, one on CoreWeave, one on NVIDIA DGX. Those are the fleet the model plane can deploy models to. It can also provision those clusters for you if you want, or you can bring your own. And then at the top of this architecture diagram, you can see these model deployments. Those are the users of the inference platform, machine learning teams, or whatever you want to say, deploying inference models, deploying LLMs basically at the moment to model plane. And what's not shown here is that we also have like a routing layer, a centralized routing layer, so the model plane, control plane can give you one API endpoint for, let's say, DeepSeek that's shown there, and that could actually be running on like 3 clusters behind the scenes, and it'll route across them. That's the 100-foot view of what model plane is. Does that make sense so far? Cool. I'm going to jump over to showing you some of the YAML of how this works together so you can get an idea of how it's set up. Like a lot of things in the Crossplane world, it is all about the separation of concerns. When we really thought about this, we realized that, as far as we could tell, a lot of the time, there are 2 teams collaborating to make this happen. There's a platform or cluster or sort of capacity team who are spinning up the clusters, spinning up the inference clusters, or more broadly, have a whole bunch of GPUs in racks and want to make them available so that people can run deployments on them. And they have opinions about what hardware they want to make available. They're probably going to have opinions about who could have that hardware, what, how much cost people can spend, policy, things like that. And then at the front end, you have machine learning teams, or very broadly, people who want to deploy models and use them for something. Could be app teams within an organization. Could be like the customers of a neocloud, potentially, if they chose to use this as their sort of orchestration stack for their cloud. And these people want to deploy a model. They probably know a little bit about models. Like we're not trying to dumb down what is required to go deploy DeepSeek on VLM or whatever. Those people come and they say, here's my recipe, here's what I want to do. And then model plane kind of marries the two together. It says, okay, someone has advertised all of this cluster capacity, someone has this model need. How can I put them together so that we can serve this one? I do see that there's stuff going on in chat. Just as a reminder, I'm not looking at chat, so please, feel free to unmute and ask a question if you have any thoughts that you want me to answer. All right. So with that said, let's show you a bit of the YAML, and then I'll talk about how we built it. So did that work? Can you still see my desktop?
I still see the model plane website right now. And Nick, I'll try to keep an eye on the chat too if any questions come up specific to what you're talking about there, and if folks don't interrupt, I'll bring it up.
Cool. All right, so you should now be looking at my editor.
Yes.
I was just talking about the two teams. This is primarily what the platform team deals in. Here's an example of some of the YAMLs for model plane. This is defining a node pool. It's defining mostly the shape of a node. It's saying, it's described as like, this is a BYO cluster, so this is not GK or EKS or whatever. This is something that you bought to, it might be bare metal, something you've bought to model plane. And you're telling model plane, the machines in this particular pool of this cluster have 8 NVIDIA Hopper GPUs with this particular CUDA compute capacity and this much memory. And they also have 8 of this kind of NIC in them. If you've used DRA in Kubernetes before, which I believe stands for Dynamic Resource Allocation, this will look very familiar to you. This is how nodes in Kubernetes, modern Kubernetes versions, was it 1.34 and above, I think, are able to express the hardware they have so that the scheduler can schedule to them. We basically copied this for model plane, and this is how model plane node pools in a cluster advertise what capacity they have. So as a platform team member, you're deploying these clusters, and for each of them, you're saying, hey, this is the capacity it has. So the model plane knows when someone asks for a model, where to send it. Let's show a model deployment. Then from the platform team's end, sorry, from the ML team's end, let's actually see if I can find you a slightly simpler model deployment for this one. Here's a really simple model deployment. So this one's deploying Qwen 3 8B, which fits on one node with as long as the node's got about 24 gig of memory, or 20 gig of memory, I guess. And this is super simple. It says this particular model deployment has one engine. Engine is what we call VLM or SGLang, etc. That engine, I'll jump over this for a second, has one container that is VLM version 0.23 running this model. Super simple, very, very minimal. And then it has a DRA-like selector that basically says, this needs to go on a node that has 20 gig. And this is very similar to what the Kubernetes scheduler using DRA does to schedule a pod. But for us, what we're doing is we are not scheduling a pod to a specific node. We're just putting it on a pool of nodes that we think is going to have capacity. And then Kubernetes kind of takes over from there. The real Kubernetes scheduler that's much more performant and optimized than ours figures out like the specific node placement across thousands of nodes. We'll probably be scheduling across, I don't know, hundreds of nodes pools or something like that. Jumping back up here, you can see here there's like this is a more advanced one. This is deploying Qwen 3 Coda, which typically does not fit on one node, even if it's got a lot of GPUs. So this one has 2 engines, or rather one engine with multiple members that are arranged in a leader-worker configuration. So you can see it says the leader needs at least 120 gig, has tons of flags here. Like I say, we don't hide. We're not trying to make it simple or we're not trying to abstract what deploying a model involves. We assume the people who are deploying these models want to optimize their flags. And in fact, that's one of the philosophies of model plane. we don't get in the way. If a new engine was shipped tomorrow, TLLM or whatever shipped tomorrow, there's a high chance that Model Plane would support it because to us the engines are just containers that we send out there. So this one has the engine is split into a leader member and a worker member, and they both require the same GPU memory. The only real difference is they'll have slightly different flags that they are passing along. Then on top of that, when you make a model deployment, this one says one replica, but let's say you had three. That means that Model Plane is going to stamp out 3 model replicas that look very similar to this. They're going to potentially get scheduled to different Kubernetes clusters, different inference clusters. And then doing that, there is no routing set up at that point. You've just deployed the models, but there's no way to actually hit them from a centralized place. So you can then deploy a model service in front of them, very much like a service in Kubernetes. It'll match all the model endpoints of these models, and it'll route across them. And the nice thing about this deployment service abstraction, very similar to Kubernetes, is that you can have 2 model deployments behind the same service for something like A/B testing of models, right? A slightly newer version on one of them, or you can match only some of the endpoints of a model deployment to say, let's take one cluster out of service or something like that. Another neat thing, I don't know if this demo is actually going to show it. Yep, there you go. Another neat thing is you can just write your own model endpoints, and the model endpoints don't have to be things that Model Plane put together for you. So this is kind of like an external service in Kubernetes, I guess. Or not really, it's like an external endpoint. So the model service can basically say 80% of traffic goes to the model deployment that Model Plane has set up for you, and 20% goes to some SaaS provider, as just in case. Been going pretty quickly. Does that make sense so far? I'm going to cut over from what Model Plane is. Any questions or comments about what Model Plane is before I start talking about how we built it? All right, not hearing anything, so I'm going to jump into how we built it. One of the really cool things about Model Plane, to me, is that it is all crossplane. It feels a lot like a pretty advanced Kubernetes operator. But we built it entirely as compositions, entirely using Crossplane. There's no bespoke or custom code, no controller runtime or anything like that. Right? As much as I love controller runtime, it was nice to push the limits of Crossplane to see what it can do here. So we are using the new Crossplane CLI that Adam and friends have put together that has this control plane project concept in it. And I chose to write all of the functions in Python because that's my preferred language for working with composition functions. We pushed Crossplane in a couple of different places. The first that you might see here is that this, if anyone's used the UP CLI or the early Crossplane CLI, you'll probably be familiar with this control plane project that basically tells the CLI how to build this into a configuration for Crossplane. And typically you would have an array of functions, or it would just auto-detect functions from in this directory. One thing that I added recently is rather than just being a directory that the CLI builds for you, which is what it would normally do, it would build an OCI image for this and then turn it into a crossplane function, which is a special kind of OCI image, and then sort of deploy it. This basically says leave the normal OCI bits to some other build system. Still, CLI, I want you to turn this into a crossplane function. I want you to put all the metadata that the crossplane package manager needs, but don't worry about building it as an OCI image. In our case, we use Nix as the build system for this repo. So Nix does all the building the function OCI images for us. And then we just sort of wrap them into a function here. So it allows us to just have sort of slightly more consistent CI. We're able to sort of build images exactly the way we want, hermetically in CI, test them. The other thing that we're taking advantage of that is relatively new is some work that Adam did so that these functions are just regular Python projects now. So this means if we want to pull in, these are kind of just the normal dependencies, but if I had an example somewhere, let's go to compose model deployment. We actually use the Python cell libraries here. Up until recently, you weren't able to use third-party libraries easily in your functions. Now you can. So that's pretty neat. One of the reasons that I really like using Python is I don't have any great examples of this, but I often think about using Python for compositions is I often think about how does a configuration language scale, right? If I was telling someone to start out today with Crossplane and just giving them my advice as to what they should use to write their configuration, there are few languages that can scale down to the point that if all you ever really end up needing to do is like stamp out one fairly simple resource, just composing an RDS instance or something like that. I think the pydantic models that we have in Python can make that feel very much like a configuration language. You don't feel like you're programming. It's not too scary. I think the Starlark language in Bazel is a good example of this, right? It sort of is Pythonic, but it just looks like a configuration language. But if you turn out that, 3 years later, this thing has grown and it's now a monstrosity, right? And it's now got a ton of logic, you're not likely to hit walls with regards to what you can express, right? And I think model plane really stretches the upper bounds of what we can do there, right? So if you jump into this function here, this is our model deployment function, and you look at this, like this looks a lot more like programming than it does like a configuration language. It was really fast to prototype. We used a lot of LLMs to help with development here, and LLMs are quite good at writing Python, it turns out. I got a lot of that represented in their training data. And basically what we've ended up doing is for every function, we define a composer with a compose method. Every time the function gets called, Crossplane's doing the normal thing, it's passing it the XR, all the compose resources, hits this compose method, and then we're able to do really advanced things like this compose model deployment function has an entire scheduler that is basically what's the word I'm reaching for here, like a pure function, I guess. Given its inputs, it will always return the same scheduled outputs, right? So we feed into this scheduler the model deployment that you've created. It looks at all of the clusters in the system. It looks at all the replicas in the system. It looks at how many replicas you want. It goes through 2 phases where it just keeps everything on the clusters they already are as long as they still fit, and then it fills in the gaps. And doing this, it was a reasonable amount of code, but very possible to do with modern crossplane. There was no cases that I remember where I was like, oh, I wish I had a full controller here, right? So I think this is kind of neat because you could ask the question of why not just use Go and control the runtime, and I think you absolutely could to do this. But one of the neat things I see here is that Crossplane is going to scale down to your needs a lot more, right? If you have a really simple place that you're starting out, I think Crossplane is going to be much simpler there than writing it by hand. And I think we've proven that you can start there and you're not going to need to like rewrite it someday when things get advanced. You can scale all the way. All right, I think we're a little bit over time, so I'm going to stop now. Didn't get any questions or comments or anything like that, so I assume you all followed along and everything's great. I see there's 21 messages in chat, but I can't see what they are.
There was a lot of discussion about Python as the favorite language, Nick. But yeah, John actually asked a question too at the end before you switched over to the implementation about like using the routing or the service or whatever it was. I'm sorry about like taking traffic and sending it to AWS Bedrock. Is that like something that's possible with that?
Yeah, right now the way we describe it is that it can send traffic to anything that is an OpenAI compatible endpoint. That's not actually strictly true. We need to test this, but I believe it would support like Anthropic, etc. as well, their style of API. But yeah, the general idea is you could create a service, put it in front of your model deployments, and as long as Bedrock was giving you back a URL that could serve inference requests, you can put that behind there as well. So some of the gaps that we have there at the moment, we don't have weighted routing yet. So if you were to put that Bedrock behind it, It would just, split the traffic relative to the amount of endpoints that are there. We don't have authentication for those endpoints yet, right? I imagine Bedrock's probably going to have like an API key or something. But that's easy to add. We just shipped V0.1 and we just didn't quite get time to do that. So that'll come in really soon.
Are you guys planning on supporting like pod groups, like these scheduled pods underneath, right? Eventually.
We already use leader worker set, depending on the shape of the engines that you put out there. So if you're doing a single node, if you're doing a deployment of a model that fits on one node, we'll just use a deployment, right? Like which since it's a pod, there's no gang scheduling. But if you tell us that you need a shape where there's leaders and workers, and they need to for the model to serve, multiple pods need to coordinate with each other, we'll use a Kubernetes leader worker set. Think we have some ideas about potentially using other gang scheduling primitives like pod click set, things like that from Dynamo, NVIDIA, Grove. One of the big questions we have that we need to figure out is like how to pick. Like, there's in a couple of these places in inference, there's like a few different projects building similar things. And we don't really want to be opinionated. It's not that we like one more than the others or anything like that. It's just often if there's like three different ways to do something, like it's not obvious like when we would pick one versus the other as optimal. And we also don't want to necessarily give everything as an opt to the user. Does that answer your question though?
Yeah, I think so.
Cool.
All right. Any other questions for Nick? All righty. Well, yeah, Nick, thanks for sharing the work that you've done on model plane, kind of explaining it, and then showing us some of the implementation. Like one of the things that was quite exciting for me, and then I imagine for the rest of this group too, is that this is a really interesting demonstration of how powerful of a project you can build, using the framework of Crossplane and the primitives that Crossplane offers. So seeing like this much functionality built entirely using, Crossplane and functions and composition, et cetera, is really quite invigorating. And I'm pretty stoked about that.
Yeah, one of the things I really liked is I've been working on Crossplane for like, 8 years now, right? But I don't get a lot of opportunities to actually use Crossplane to build things, which is not for lack of trying. We've talked about it before, but often it's kind of contrived, right? It's like, let's come up with some reason that we can use Crossplane for something, even though, my job is mostly open source maintainer. I have a 15-year background as a platform engineer, so I am rooted in the problem set, but I haven't had to do it since I started working on Crossplane very much. So it was nice to have a real problem that, has sort of real walls that you can bump up against to work through here. I feel like there was a small handful, at least, of issues that people had come to me wearing my like Crossplane maintainer hat, and I'd be like, no, we're not going to do that. And then, I hit those same issues, and I'm like, oh, I empathize now. Like, I can sort of see where they're coming from, and it helps me, know what to prioritize.
Well, Crossplane is the better for it then.
Right.
All right, awesome. So looking forward to seeing more developments on monoplane and potentially more upstream fixes as well. So I think there's one more thing on the agenda. Ayush, did you add this one? I imagine it was because you look like the author of the issue as well. So I wanted to make sure that you were able to bring this up too, my friend.
Yeah, I'm really sorry for adding this up on a slightly last moment. So yeah, I also asked the questions on Crossplane Slack as well. So the thing is, yeah, so I'm from Atlassian. We are kind of using Crossplane V2. And we wanted to use this as one of the feature, which is setting up per node pool subnet. And when I was exploring Crossplane V2 provider, like GCP latest provider config, sorry, the schema, and it doesn't have it on the for provider, like it is there, readable at provider. So then I started looking into things, and we had similar 5 to 6 reasons or 5 to 6 features actually, which we want. And the reason they are not there is because behind the scenes Crossplane still is using Terraform 6.47, whereas our features started coming in from 7.24, like the Terraform provider Google. Um, yeah, it's 3.4. I've written it, but yeah, it's 2.4 bare minimum. So, I mean, two questions initially. What's the like? Is there any plan moving forward for having the bump up, or is there any specific schedule? Is there like, or is there any different call like for that matter? Like,
Mm,
I'm kind of new to these things.
We are currently tracking update of underlying Terraform provider to the latest 7 version internally.
Mhm.
There's a lot of breaking changes in resources, so we will need to release major version of a provider, Crossplane provider as well. But
Mhm.
it's tracked. We currently have that in progress. Alper, do you want to add more details or?
Yeah, so I was going to say, you know, provider update GCP maintainer Sergen Yalçın is working on this. So we have done, before Sergen, Erhan took a look into this, and after that, Sergen took over, and we have identified a couple of issues that we need to resolve. And on top of that, we would like to also, so we have already deprecated the V1 Beta 1 versions in the 2.x series of provider GCP. And with this bump, we would like to release provider update GCP v3.
Mhm.
And we would like to also remove the already deprecated V1 Beta 1 APIs. So
Correct.
the scope is quite large for the upcoming GCP, better GCP release. We will do a major version bump, and
Mhm.
it will take some time, but we are actively working on this.
Got it. Is there something open which I can also track, like what issues are? So what I'm going ahead with is I'm trying out my internal forked out of 2.60 version of provider, and I'm trying to bump it up to 7.35 and trying to make it run with a crossplane function setup we have, lab setup we have. Uh, One issue I found is with the field. I'm trying to forget. I can share that, but it is with CPU CFS field. It got required now, I think. So in the node config. But yeah, that was the only main breaking change. But yeah, I'm trying to find out. Like, it would be very good if you can share some findings, some breaking changes, so that we can I also can get some help. I was thinking to raise a PR, this 944, to have a bumped up version on top of 250.
Yeah.
But if it is already being tracked and there are major versions, we can decline this PR, or I can work on it. Um,
Yeah, I mean,
Anything?
we are aware of this PR, by the way. We had previously discussed this PR with Sagan. I think Sagan was going to leave a comment on this. No comments. Uh,
Yeah, I think
yeah,
it got.
so I mean, maybe what we can do is we can open a tracking issue for the V3 bump
Mm-hmm,
and list what we are planning to do in that issue so that folks can track it there.
mm-hmm,
But since the scope is quite large,
right.
uh, getting this PR and merging it, then we would have the main branch broken. That's why we didn't want to move forward with this PR. So the bump is unfortunately is quite involved.
Mm,
Internally, we needed this bump, but we had to resolve, it via other means, deferring this bump because we didn't want to rush the bump.
correct.
Yeah, so what we can do, as I mentioned, is we can open a tracking issue in the repository so that you can also track it.
Right.
And yeah,
Yeah, I have a issue with opened. I mean, that is specifically for no, per nodeful subnet support. We can link that to that issue, or yeah, a new issue. Anything is fine.
okay. So
Uh,
with the issue, I mean, we can list what steps we are planning to take for the bump.
okay. Yeah, that's even much better actually. I'll try to do the same on my fork, and at least use that for a while till V3 is released with a bumped up version.
Okay.
And yeah, I think that's all. Is there? I saw there was a sprint board, but yeah, is it tracked there, like the work happening on the bump up also?
So I think we are currently internally tracking it
Okay.
in our own software.
Mhm.
But it makes sense to open a public issue so that it's
Correct.
more visible. Thanks for bringing that up.
Yeah. Sorry, last thing. I was yeah, while I was trying to resolve it for my fork, I saw that the provider version, sorry, yeah, the provider module it is Go mod it is using is, I think, Upjet fork, like the provider Terraform provider itself is being forked with the hyphen Upjet tags and then getting used into the GCP provider. Is that so? And is it going to be continued the same way?
Yes, that's what we call as the no fork architecture. I think that's what you are referring to. Uh, so are you referring to the private upbound fork?
Yes, correct.
Okay,
Yeah.
okay. So as I mentioned, we had to add a new feature to the provider, and in order to not to rush the V3 bump, we relied on that, private fork that we are also using for AWS and Azure.
Mhm.
But when we do the V3 major bump, we are planning to revert it back so that
Got
we
it.
don't need to maintain that private fork.
Makes sense. Cool. Sounds good. Is there a rough time? Like I know usually it will take time, but yeah, very rough time you have in mind, like so that I also put that much effort in my fork, or maybe not. Huh.
Yeah, I mean, it will take 1 month or so.
Hmm.
I don't expect it to be earlier than that. As I mentioned, the scope is also quite large.
Yeah, yeah, makes sense. But would it even may take more than 1 month? Like because we internally have a buffer till 2 months. So if you are anyway releasing, then I want to work on it probably.
Yeah, so what I would suggest is, let's open the tracking issue and then, you can track the progress there.
Mm-hmm.
And then we can discuss, how
Got
it's going. So it's a little
it.
bit early right now.
Yeah, yeah, yeah. Completely makes sense. Yes. Thanks a
Thank
lot.
you.
Cool. Well, great discussion here. Man, Albert and Jonas, it's always really useful to have you folks on here on the calls too for ecosystem broader scope things. So thanks for your attendance today as well too. Yeah, so that's everything on the agenda. Went through a bunch of awesome stuff today, so we'll keep working on 2.4. Thanks, Chris and Nick, for showing off the work that you all have been doing. And yeah, let's keep on charging. Thanks for being here today, everybody.